Well, this will be also a short lecture on limits at infinity. So there's a couple things to remember. Infinity times infinity is positive infinity. Positive infinity times negative infinity is negative infinity. Negative infinity times negative infinity is positive infinity. So these three, they follow the same rules as any other constants. Okay? The important thing that we need to go over is 1 over infinity, and that's equal to 0. Okay? So let's think of it like this. Let's say you have $1 and it's just you. You have $1, right? Now let's say we split that dollar with 2 people. Now each person has 50 cents. You split it with 10 people, each person has a dime. 20 people, a nickel. 100 people, a penny. Split it infinite number of times and you will basically have nothing. Okay, so here are a couple examples that we're going to go over. So let's look at the limit as x approaches infinity of square root of x. So if you think about the graph looks a little bit like this, and it shoots off to infinity, right? So this is going to equal infinity. Okay. Same thing with e to the x. If you look at the graph, it looks like this and shoots straight up. Okay, so this is infinity as well. Okay, let's look at the limit as x approaches infinity of sine of x. Well, let's look at the graph of sine of x. It looks like this, right? And it goes on forever. It never gets above 1 and never gets below -1. So then what is it? It's nothing. It does not exist. The limit does not exist because it never really approaches anything. If you give me a number where it approaches 1, I can give you another number that's greater that approaches -1, right? Okay. Now let's look at limit as x approaches infinity of 1 over x. And so if we plug that in, we're going to get 1 over infinity. And earlier we said 1 over infinity is equal to 0. Okay. Now looking at limit as x approaches infinity of sine of x over x, we can treat sine of x as a constant. Sine of x is between -1 and +1. So we can almost treat it as a constant as we go to infinity. So it'll look something like 1 over infinity, which then will also be 0. Okay? In this case, let's look at limit as x approaches infinity of x over sine of x. So it oscillates between -1 and 1. So it's going to increase and then decrease and then increase and then decrease and then increase. So as you can see, it keeps switching back and forth again. So it never really converges on anything. So this one also does not exist. The limit as x approaches infinity of e to the -x. When we have a negative in the exponent, we can rewrite the function so it's reciprocal. So 1 over e to the x. And then if we plug it in, we get 1 over e to the infinity, which of course is 1 over infinity, which then becomes 0. Okay. Now if we look at polynomials, we can see take the limit as x approaches infinity of x plus 3 all over x squared. Okay? What you want to do is look for the x with the greatest power. So we know that the greatest power is a multiplicity of 2. Okay? So everything else that does not have a power of 2 would then cross it out. So we're left with 1 over x squared. Of course, we're taking the limit as x approaches infinity. And then we're just going to get 1 over infinity, which then becomes 0. Here, the biggest power is 3, so everything else will cancel out. Cross it out. There you go. So we're left with limit as x approaches infinity of x cubed, which is then infinity. And then, same thing, we're going to look at the powers. There's two of them. And then everything else will cancel out. And then so we're left with limit as x approaches infinity of 3x squared over 9x squared. But notice the x squared cancels out, and you're left with 3 over 9, which is then equal to 1/3. So that's the limit as x approaches infinity. Can actually still be a number. That concludes the lesson for today.